Well, if I just talk right here, it's on? Okay. Good morning, everybody. Woo! Yay! Okay. It's awful quiet in here. I don't know if that's a good or a bad thing. We're going to go ahead and get started. Oh, I forgot to ask you how I can I click on something up there? You can do it for me. If you could just click on that, on the link that says Let's Get Professional Training in the middle. Keep going down a little bit. There you go. Okay. Got it. Okay, cool. Okay, so good morning again. I'm Denise Delaney. For those of you that don't know me already, I hope I get to know you today and in the future. I want to welcome you from the whole Grow Green team. We're an interdepartmental team. The city departments actually talk to each other, and we help support each other in doing outreach that has to do with landscaping. So I do want to thank my partners here today from the Planning and Development Review Department. I have the two Leahs. I have Leah Gibson. Leah, would you stand up? Yes. And Leah Haney over here. And they both are just fabulous folks to work with, and they helped a lot in putting today's program together. These bright lights are on because we are taping this. So you'll be able to watch the videos in the future. We don't have the first ones up yet because they have to be edited. The PDF presentations from last time are up. Could you please click here for frequently asked questions? It's right above the picture. Right there. And then, well, that's not what I was thinking. Does it show the questions on there? I'm sorry, I thought I'd be able to do this. Okay, there we go. I just wanted to show you that page because that's where all the presentations are. So you go to the Landscape Professional Training page and then look under Frequently Asked Questions. And you can see the PDFs of the presentations from last week, and the ones from today we'll have up tomorrow. Please turn off your phones. If you haven't found the restrooms yet, there's some across there, and there's some back over here by the phones. We have a stamp for your parking. If you're city staff, you just sign the clipboard. But if you're here as non-city staff, we get your ticket, your parking thing validated so you don't have to pay for parking. We are going to have an hour and 15-minute lunch unless we go over. I built in a little bit of cushion because sometimes speakers talk more than they're supposed to. And I do have a list of restaurants nearby that I'll put out there at the break. So if you're not familiar with the area, you can find a new place to go. So with that, could you go ahead and put my presentation up now? So today, I'm actually your first speaker. And, oh, God, I'm up on the screen. Okay, so today I'm going to talk to you about plants running hot, cold, and dry. I'd put hot and cold in there, and then I thought we need to talk about plants being dry as well. So, well, while he's getting that up, okay, go on to the next one. Oh, I go on to the next one. I'm sorry, you guys, I'm so nervous. Okay, plants running cold, hot, and dry. And I also wanted to point out that the Grow Green program, we are partners with the Travis County Extension Office, and we have Daphne Richards. Where is she? She's our Travis County Extension horticulturist, and she has a guest. And then the Master Gardeners that she works with, they help support our program. They distribute a lot of our materials. So where are the Master Gardeners in the room? Thank you. Let's give them a hand. Thank them. They do a lot of great work. We also have a Master Gardener out at the table, so if you want to thank her for her volunteer work and helping us promote Grow Green, we really love being partners with them. So people expect a lot from their plants and their government. And I've been in both worlds, and I can tell you, we do expect a lot, but we should expect a lot from plants if we care about breathing and eating and shelter and medicine, because plants are really the foundation of life on Earth. And I think sometimes people forget that. Maybe you guys not, but in general, they really are important to us in so many ways. So the main thing about which plants you're going to choose here, there's lots of climatic factors, but temperature is one thing. one of the main things. So just looking at our seasons, you know, right now we're in spring. Summer, of course, it gets really hot. I put possible drought conditions. I put this slide together a few years ago. It's like probably guaranteed drought conditions. And then in the fall, it cools off a little bit. Of course, that's a great time of year to be around here. Our average first freeze is in November, at the end of November. And we might get some snow, you know, a quarter inch that shuts down the city. But it's more about the temperatures and how low they go and how long they stay low that affects the plants. So plant hardiness is genetic, and each plant has, you know, a temperature range that they needed for growth. And we have cool season plants and warm season plants. But generally, plants max out once it gets above 86 degrees. So in the heat of the summer, they're not growing. They're just like hanging in there and trying to, you know, survive until it does cool off a little bit and they do get some moisture. And also, hardiness can be a function of location. And what I mean by that is I have that Salvia farinacea. If you're growing that here in Austin, it may very well act like a perennial. But if you're growing it up in Dallas, you're probably going to treat it like an annual. So the weather is affecting it, but the same plant can respond differently based on the extremes. So cold hardiness, really what that means is the ability of a plant to survive the winters in that particular area. And you've probably seen the cold hardiness zone map. But I wanted to point out that's based on the average temperature, extreme annual temperature. So it can get lower than 10 degrees Fahrenheit, you know, if you look at all the averages. Austin is in hardiness zone 8, and our average animal minimum temperature is 10 to 20. Now, honestly, we don't look at the plant zones when we did the plant guide because we already know that these plants do well here. And I do want to mention this because this is free to Austin citizens. You guys can get them for your clients, for your neighbors, for your garden clubs. You just give me a call. You can come over to our office across the street at One Texas Center, pick up a box or two or however many you want because that's how we get the word out. Also, if you have any input or comments, please send them to me. I do listen and I do take those to heart. When we revised it last time, I invited 40 external stakeholder groups to participate and 15 took me up on it. And I invited 40 city staff to also participate. So this guide has a lot of good information in it, but it's not perfect and we can always do better. So if you have input, please let me know. And get as many as you want. You want to guess how many we distribute every year? Anybody? Nobody? How many? 50,000. No, 60. Well, between 50 and 60,000 of these a year, and they go all over Central Texas. The other thing I wanted to point out is these are not all the plants that will do well here. You know, there's a whole bunch of other ones, and as a horticulturist, it's, you know, we have this much room. So I just wanted to mention that because there's lots of plants that do well that we haven't highlighted. Okay, so why are plants susceptible to the cold? Especially because they have so much water in their cells. This is a comparison of an animal cell to a plant cell. And so plant cells have rigid edges and animal cells don't. And then they also have chloroplasts where the chlorophyll is, where the sun shines and they convert sun energy into sugars. And then they also have the vacuole, and that's the big water pocket that's in there. So if you think about when that gets cold and all that water in there gets cold, it's going to have some effect on the plant. So these were just general estimates. I kind of searched around to find some numbers, and generally herbaceous plants are about 80% water, and woody plants are closer to 60%. But then there's some like aquatic plants that are 95%, and even cacti when they're fully inflated, I guess is what I'd say. So how do those cold temperatures injure a plant? Well, one way is those ice crystals form inside the cells and then they burst. And so you get like the cactus up there. Those cells are never going to come back. There's really not anything you can do about that cactus because that vacuole has ruptured in there and it makes it all mushy. So you kind of just leave it like it is or you're going to have to replace it because there's really nothing you can do about that. The other way that temperature affects it is when the water is in between the cells, and that's when plants get really dried out. That's a sago palm. I took that picture a couple years ago, and it looks like it's dead, but actually the sago palms recovered quite well that year. They're really, really pretty tough, and it was in an urban area and a microclimate too, so that, and a little protected, so that may have helped. But those are the two main ways that cold temperatures injure a plant. What's really super cool, it's one of my favorite things, is that some plants have antifreeze in their cells, and it's not just plants, but some fish and insects and bacteria, and they have these proteins that hook up to the ice crystals to keep it from rupturing. So basically the plants have antifreeze in their cells that allows them to take colder temperatures than other plants. I just thought that was super cool. Another way they deal with the cold is they just drop their leaves, and deciduous plants, of course, do that. When it starts to cool down, that gives them a response to start doing that. And then, of course, when things start to warm up, they leaf back out. They're pretty smart that way. Oops. And then a lot of plants just die back. That picture at the Wildflower Center, that was taken like in 1995, so you can see there weren't even any trees there. Yeah, those first couple of years were a challenge when people were expecting to see lots of wildflowers and we were still planting them. But you know this, lots of perennials, the top dies back and then they come back up from the roots. Some plants, like yellow bells, you think they're dead and you cut them back, just wait, because you can always wait longer and see if it comes out. If it's warmed up and the spring's going and lots of other stuff is growing, then maybe not. But a lot of those plants will come back up from the roots. So if you're trying to guess one way or the other, my suggestion is just to leave them and wait and see and give them a chance. Another way that woody plants, this was basically birch trees that do this. They have narrower xylem and phloem, the transport cells that carry the water from the roots up to the leaves and back down. And so they're narrower, so they don't have as much water in them. And so that's how they deal with cold. And then there's acclimation. This is hardening off. This is like when you have the plants out in a greenhouse, or you have them in a greenhouse and you want to take them outside, but you need to put them like in a shady area for a couple days and just kind of let them get acclimated, because if you take them from one extreme to the other, they're just like us. They're like, oh, I can't handle that. So some plants do that with cold temperatures too. It's like if you gradually get colder and colder, you get acclimated, but if it happens quickly, then you have more problems. The exposure to cold, sometimes the temperature just goes down, comes right back up, and that's when we see damage like the hibiscus there. It might just be the tips of the leaves, and so the plant's really okay, but it just sort of nipped it in the bud. Maybe that's where that came from. And then annual plants, they figured out a way to do this. They just don't exist. And they wait till the conditions are right before they germinate. So that's how they deal with cold. But I was always, when I first moved to Texas, it's been almost 30 years ago, and I'd see bluebonnets when it did snow, and I thought, they're not going to make it. But they do. They hunker down to the ground, and they must have some of that antifreeze in their cells. And so the wildflowers have adapted to this, and of course they do just fine. Oops. So as far as, there's also heat hardiness, and this is much newer than the cold hardiness zones. And this is from the American Horticulture Society, and this is based on how many days, heat days, that the temperatures are over 86 degrees, because 86 is kind of the max point where the plants are growing. So if you're way up north, you have less than 1 day that's over 86 degrees, and if you're way down in the tip, you have zone 12. So again, it's kind of like the cold hardiness map. I think it's very interesting information, and I think as we deal with our climate change that we're going to be paying way more attention to this kind of stuff. There's actually another climate map that was done. I can't remember which organization did it. And it's way more complicated, and it takes into consideration not only the highest temperature and the lowest temperature, but some other weather variables. So I think might be a little premature. We just had Andrea, who's going to be here later at the Wildflower Center, had a conference with people from public gardens all over the country last week, and they were talking about, well, should we change our plant palette? It's like, well, we kind of have to see how things go. I mean, we can think about plants that grow further south as potential ones that we're going to be using more of, but we kind of are going to let the plants sort themselves out too. So when we're talking about climate, macroclimate, that just means climate. That's all the big picture stuff that creates weather patterns over the whole world. But I wanted to talk to you just a little bit about microclimates, because that can really affect the range of the plant and hardiness based on where they're planted. So the microclimate, like it sounds, is just a smaller area that has some kind of influence. So even a tree canopy, it produces shade, it increases the humidity, it lowers the temperature, and so there really is a microclimate underneath trees and other shrubs. Of course, slopes. Oops. I drive up the service road on off I-35, and there's been rosemary blooming on the south side bank of this wall for like over a month because it's on that. Oops. It's on the slope. It's on the sunny side. So that's something to take into consideration, that you're going to get an extension of their heat hardiness if you plant them on those sunny sides. And then, you know, just heat island effect and how close they are to buildings. I mean, if you have plants that are here in the urban center, they're, you know, the temperature is, you know, at least 4 or 5 degrees warmer here than it is if you just go right outside the city. So that's something else to take into effect as we have more and more people in the cities and we're growing more plants here. You know, like I went on one of those fabulous master gardener tours and somebody had espaliered an apple tree. And actually those need cold temperatures, but if you just, I guess the point is that you can grow other stuff here if you find a spot that makes it happy. And then bodies of water, that picture of Lake Travis, I think I took that in like 2007. And this isn't the greatest picture at the top. Does anybody know what that, that fruit is in that top right-hand picture? It's a fig. That's a fig vine. And I have never seen a fig on a fig vine. Have anybody ever seen one? Fig ivy? You've seen figs on them? I mean, I just never, and I didn't know because it was pretty close to Lake Austin if it helped it mature more, but I just kind of wanted to throw that in there. So water bodies can definitely moderate temperatures. And if there's not any water, sad picture, then of course it's not going to have that effect. And then, of course, altitude, you know, this is just a basic diagram of tropical temperate going up the hill. So, of course, it's colder when you get up high. And then these are two different pictures of Lake Austin. One of them is overlooking Lake Austin, and one of them is right across from Emma Long Park. And there's like, I don't know, couple hundred feet distance between, you know, way up on that ridge and way down below. So there's lots of little microclimates in between. It's not. And then if you put plants in raised beds, of course, the soil isn't insulated by the other soil around it when you get it up above the ground. So your plants are going to be more susceptible to temperature changes. Not to say that they won't do just fine. That was at the Wildfire Center. And I think containers are a great option when we have limited soil choices in some places. But just keep that in mind when you get it up above the ground. That it's not going to be as cold hardy. And then the color of the ground, we know that dark color attracts light, so dark sand is going to be way hotter than light sand. What the soil moisture is like at that time, sandy soil is going to heat up a lot more. There's a lot more air spaces in it, so it's easier to heat up. Plants that otherwise might be hardy to your zone, if they don't have good soil moisture, like that, they say watering your plants before a freeze, like not that day, but if your plants are well watered when a freeze comes, it does help insulate them, and that soil moisture has something to do with that. So if it's bone dry and then it gets really cold, the plants are going to be more stressed. And then this is kind of like the tree canopy. Just even underneath one shrub, you can have different little microclimates based on what those plants are doing there. And then humidity, you know, when it's really windy, it just, I mean, when the humidity is high, the plants don't lose as much moisture. So when we have hot, dry winds, that just sucks moisture out of the plants. And then the other thing, because drought is just like something we talk about all the time, I wanted to go over just, you know, quickly different ways that plants deal with drought. One is they just avoid it, like the annuals do. A lot of them have figured out ways to store it and save it. A lot of them have figured out ways to reduce water that they lose through their leaves and transpiration. And then some have adapted different ways. And many of them have combinations of these. So they've figured out how to be tough in Texas, because you got to be tough to be a plant here. So again, just like with the annuals and the cold, you know, they don't start growing until they have moisture. It's the same picture because they're the same plants. A lot of plants have those underground storage organs. This is a spider lily, and look at all that's stored in that corm below the ground that you don't even see. But that's one way. If the top dies back, it's got all that reserve, that it can sprout back out. And then, of course, we know about succulent plants. They hold a lot of water in those leaves that helps them get through the drought. And then this, I wanted to just talk about stomata because they're really important to this. That's a picture of a leaf surface, and actually stomata are holes in the leaf surfaces that exchange gases in and out. So I've always been a little confused about guard cells. So if they're collapsed, they don't have any water in them, and so they're keeping the water in the plant. When the water gets hydrated and those bean-looking things fill up, it opens them up. So then, you know, water can still go out the leaves. So one way that plants deal with drought is they shut those stomata so they aren't losing any water. So I just thought that's a super cool picture too. We don't always see plants that way. So one way they do that is with gray or hairy leaves, and that actually kind of shades the surface of the leaf with the fuzz, and it helps reduce the amount of transpiration that's happening. So lamb's ears and woolly stomodia are two examples of that. Another way that plants do that is they have a waxy surface on their leaves. So, of course, if it's covered with wax, it's not going to lose as much water. So cherry laurel is a good example of that one. And then a lot of plants, we know they have narrow leaves, skinny leaves, tiny leaves. So they're reducing the amount of surface area so they have less stomates on their surface area, so they're losing less water. So that's a good indication of a drought-tolerant plant, is it has skinny leaves or really small leaves. And then, of course, you know, we have plants that have spines and thorns. They're just avoiding being eaten, so they're conserving their water that way. So they might have spines, they might taste bad, they might be toxic to plants. And so that's why they're like, go ahead, try to eat me and see what happens. And then, of course, plants go dormant. I love buffalo grass personally. This buffalo grass is up in northwest Austin. That's the best stand of buffalo grass I've ever seen. And they actually did some really good soil prep. They did like 10 to 12 inches. I know nobody wants to spend the money for that, but look at that buffalo grass. That is gorgeous and thick. They mow it twice a year. It's just beautiful. But of course, with the warm season grasses, if there's a drought and you don't water them, they just shut down and go dormant. And people go, well, that's dead. No, it's dormant. They just have shut down until the conditions are right for them. So that might be a new aesthetic that we think about in Austin. It doesn't have to be green all the time, and it might be brown in the summer, and that's okay. Brown's a color. Beige is a color. And we have to start being smarter about our landscapes, obviously. And Andrea's going to talk about HabiTurf later, so if you guys have any questions. And also, I did want to ask if you would hold your questions. If we have time at the end, we can do that. But also on your agendas, I put everybody's contact information, so you can always follow up with anybody. A lot of the speakers will be around during the day if you have specific questions for them. I saw a hand over here. And then another way that they've adapted is they have really extensive roots. To tell you this, Bill Carson out at Native Texas Nursery, he told me when they were doing some construction, he found Bermuda roots that were 16 feet deep. Oh, doesn't that surprise you? 16 feet, really? That's deep, deep roots. So obviously a lot of the prairie plants have developed extensive root systems, and that's also why the prairies are so rich, because they've broken up the soil, and all those roots and all the bacteria and organisms that are happening on the root system help make that soil some of the best. It is the best in the world in the prairie. And then adapt water collection structures. Look at how those plants are shaped. When it rains, where does all that water go? It just funnels it right down to the root system. So they're like, when they do get some, they figured out ways to be smart about harvesting it. And then some of them just grow slow. This is the Queen Victoria, and it just doesn't grow very fast. So it doesn't need a lot of water because it's not growing. And then I don't want to get too technical. Luckily, I'm almost out of time. But there are some different types of photosynthesis that plants do. There's actually 3 different kinds. There's the C3 photosynthesis, and if I wanted to bore you with the whole diagram, that would be the one that most plants do, about 85% of plants. And then there are the C4 plants that are much more efficient, and then there's some CAM plants. And so I'm going to tell you just a little bit about each one. So C photosynthesis, those stomata are open during the day. The photosynthesis takes place over the leaf, and then under normal light conditions and cool and moist conditions, like when do we ever have those, the C3 plants are more efficient than the C4 or the CAM plants. But when the C4 plants come in, it's only about 3% of the plants. Corn, some are annual plants, but the one I want to point out, and the reason why I bolded, are grasses. Grasses and sedges are both C4 plants. They like it hot. So that's why your warm season grasses and most of our grasses that we grow in the landscape like hot weather, because they have a different photosynthetic pathway that is more efficient than the other 85% of the plants. So grasses are just great for so many reasons, for wildlife habitat, for erosion control, for beauty. So bunch grasses, I'm talking about bunch grasses, not turf grasses, specify. And then the sedges, and we're seeing more and more of those used in the landscape, which I find very exciting. That picture is out at the airport. They have a new call waiting center, so you can stop and talk on your cell phone while you're waiting for somebody to pick them up at the airport, and it's beautiful. So if you have to go to the airport, it's not a bad place to hang out for a few minutes. On the C4 plants, the stomata are open during the day, but it photosynthesizes faster, and they use water more efficiently, so they don't need as much water. Now the CAM plants, oh, where'd it go? Oh, well, I guess I don't know where that slide went. It disappeared. The CAM plants, I can't remember. Maybe one of you guys can read. It's like, I can't remember what it stands for. But basically it's desert plants and cactus and agave. And they can open their stomates at night if they need to. And they can shut down when it's hot. And so they they use a lot less water than the other plants do too. So it's just to help you understand the plants that we're working with on a regular basis. Let me see. I think God, you guys are a tough audience. I think we have time for a couple questions. I have 3 minutes left. So anybody have any questions? Wow, you have a question? Somebody. I'm sorry.
So there's this one book that you folks have put together about desirable plants for Boston. Are there any other really reliable resources? I keep looking for the sunset equivalent of plants for Boston or Texas.
Yeah, she's asking if there's any other sources. Well, of course, this one's a little dear to us. The Wildflower Center has an amazing database, and I was at the Wildflower Center for many years, so I'm not trying to knock that, but sometimes we have students want to do a native plant project, and they get on the Wildflower website, and they go look for all these plants that are really cool, but then they can't buy them. So you do have to look at which natives are available in the nursery trade, but they have lots of great information. If you have any questions, you can always contact us. But I don't know. I mean, there's a book that I used to use a long time ago by Sally and Andy Wazowski, and it's Landscaping with Native Texas Plants, and it's, one of the best resources that I've found. So I guess without further ado, no more questions. Okay, do you have Michael's presentation? Okay, excellent. All right, well, thank you very much. I really appreciate you guys being here today, and I hope that you found something helpful.